session effectively highlighted the value of aligning with global standards like IEC 62890. Now let's move on to the next speaker. I'd like to invite Dr. Santhosh Kumar from KBR.
Good evening, team. What I'll do is today I'll just go through the journey which KBR has taken for adopting AI. I think if you have seen from morning, most of the speakers have been talking about the operational aspect of it. So probably what I'll do today is just talk on the feed and the early design part of it and the detailed design and how we have adopted or taking the baby steps in adopting agentic AIs and AI in action in KBR. So what I'll do is I'll just quickly introduce KBR for those who don't know. Basically, we are delivering a cleaner and sustainable energy for the future. We have our own plastic recycling technology, which we license. We have hydrogen fuel license. We work in hydrogen fuel license. So basically, we license the energy technology that helps reduce sustainability in the world. How we deliver this is basically through data and data-led innovations. In the last 5-7 years, we have been taking this journey of data-driven engineering. The challenge with this data-driven engineering is multifold. I'll not go into each of them. So I think when we talk about data, I think we first need to talk about, earlier speakers mentioned about people. We need to upskill the people so that they're not just used to the drawings, but they are now used to data and they work with the intelligence the tools provide and the data which they have to work with. Second is, of course, the tools to integrate, because every engineering disciplines work with different sets of tools. How do you integrate the data? How do you ensure that what a discipline calls A is actually aligned with what the discipline B calls it as B, right? So that's what the challenge which we have. And then third one is basically adopting, because if you look at AI, I think every day you see new models. I think last year or 6 months back, DeepSeek shook the entire AI industry with their new models. And today, if you look at it, I think last week or a couple of weeks back, Google's Gemini Pro is again back. I think they have enhanced it and they are releasing new models. So every week or every month, you have a new model coming in. So how can you adopt to the speed at which the technology is growing? I think that's the other thing. Third, and the last thing which is very, very key in the agentic journey or the AI journey is the domain knowledge. I think AI is still not mature to completely replace humans, because we do have intuitions, we have the exposure, we can look at, there are some certain dimensions which humans do better, and that's where we still need to continue to leverage or depend on the domain knowledge which the engineers bring in. Right? And I think today, if you have talked about digital twin, you're talking about 1D to 8D, 8 dimensionals of data. So basically, the data is just growing. How do I leverage the existing technology to it? So what we did is about 7 years back, we laid the foundation where we started working. We understood the problem that each engineers are comfortable and will not move away from the tools and technologies they have been using, right? Like most of us here are familiar and comfortable using Excel. So if I come and ask you that, okay, just replace Excel with some other tool, I think you will see a lot of resistance. So what we said is, let's introduce technology and tools so that they are augmenting rather than disrupting the way engineers have been trained, have been working for the last 20, 40 years, right? Especially in deep tech engineering industry like oil and gas. I think the technology has been there for last 50, 60 years. And engineers have been trained to be cautious, risk aware, and to use the tools and technology that is proven, right? So if I ask the engineer to change and to be a little more risk savvy, I think you will see a lot of resistance. So that's where what we said is, let's not disturb the engineers too much. We'll allow the engineers to work with whatever tools they're comfortable with, but then we will create a data exchange hub where we get data from different systems. I think, like the earlier speaker mentioned, there is an open standard, but even though in oil and gas you have C4 standard, it's not mature. I think it only addresses 10% of the data interoperability. There are still tools where we have vendor dependency. There are still tools that doesn't talk to each other within the same vendor. So that's the challenge which we had. Hence, we had to develop our data exchange platform. And for us to build a data exchange platform, we need to start working with data right from the beginning of the project. So that's where, if you look at the way we address the journey, is I think the industry around 90s has already migrated into digitization because they're using the 3D tools and technology. It's become the standard. I think if you look at most of our engineering curriculum, they have already upskilled and made people aware and trained people with the 3D technologies. What we started working is the integrated, connected data, right? Because every discipline has interconnected data. One discipline is dependent on other. Based on this data, the other discipline needs to work, or the upstream discipline needs to rework on that data. So how do I enable this integration is where I think we are focused on. We started off with developing this connected and integrated hub. And then, since we had this integrated data, then we started introducing, I think most of us are familiar with Power BIs. So we started using machine learning algorithms like random forest, etc., to see if I can get some early alerts so that we can just provide as an insight or provide intelligence to the engineers to make the decisions. That's where we started looking at insight-ready platforms where we augmented intelligence into this connected systems. And then what we did was with the buzz of AI, and we didn't want to be left behind. So what we did was we said that, okay, we will give engineers an AI assistant so that they get, augments whatever information and whatever intelligence they have. And I think today we are slowly taking our baby steps into autonomous system. So before that, let me just give a quick introduction of what we did we started about 7 years back when we said data was key for us. So if you look at it, today there is a buzzword called construction or operation-led delivery or led designs. I think then it just moved to construction-led or construction-driven design. And hence, what we said is whatever data is required, because the end goal is at the operation and maintain, because that's where the data would add a lot of value. But for the data to add value at the operate and maintain phase, I need to start collecting data and defining the data at the conceptual phase. And that's where we started developing our own class libraries. Again, if you talk about data, I think we all will get lost in data because especially in oil and gas, there are millions and millions of attributes and data that is there. So what we did was, in our class library, we said that this is the mandatory data because this is a bare minimum data for me to provide the required intelligence to augment engineers. So that's what we defined as part of class library. The second thing which we did was we said that we can't fight the battle where we want the data to be very perfect, right? So we can't have a perfect world. So data can never be perfect. Data can only mature over a period of time. So hence, we introduced something called as object engineering, or what we call as data engineering within KBR, where we group these set of data, and wherever there is interdependencies, interconnections, connected data is required, we assign data maturity codes with the data. So that's what we had done, and of course, since we are a 100-year-old organizations, we had a lot of historical data, so we were able to tag, get the data and assess use the historical data for us. And that's where what we did was, we started off as a first journey where we took our historical data and we said we will provide an engineering assistant to our engineers. So what we have called it as KBrain. Of course, we are using existing model. We didn't train a new model. We just refined it with our data. So it can basically answer any of your questions, like example, if a new graduate is joining us, he or she doesn't get the bandwidth of the seniors. They can start asking the KBrain the questions, simple questions, and then for complex questions, they can go and connect with the mentors. And then what we did was basically, this is an example of agentic AI, a simple demo where I think earlier most of the speakers said that vendor data is a key component. And especially since our organization is project-driven organizations, vendors in US give us data sets in a different format. Vendors in UK give us different, vendors in ANZ give us different formats. Vendors in APAC give us different formats of data. So different regions gives us different formats of data. And our engineers keep struggling parsing this data, understanding this data. So what we did was we created an agentic AI model where, and for example, in engineering world, the flow gauge could be called as pressure control by one vendor. Metrics, unit of measures would be very different. So that's where we created very basic agents for us to basically understand the various workflows and how we can create an agentic workflow to address this. This is just what I showed is just a basic vendor bid evaluation data sheet because we are supposed to get bids from 3 to 5 vendors, depending on the complexity of criticality of the equipment. So this is an example where we have addressed parsing and processing the data using agentic AI framework. And what we did was, the biggest challenge was that engineers are so used to what they have been doing. Now when AI is doing their job, I think engineers are very, very uncomfortable. And right now, AI is not in a mature stage where there is still a lot of hallucinations. There are still a lot of errors. So what we did was we said we want to basically humans to augment the AI intelligence. That's what we started working towards, and that's what we said our user experience would be, where we said that AI would identify and basically say that, okay, these are the areas I'm not comfortable or I have failed, or these are areas where the probability is very low. How can basically then I just email it to the engineers and the engineers would review that data, validate that data, or modify that data. So that's how we have just implemented this. And then basically what we said is we took the entire journey. This is an example workflow for mechanical equipment data sheets, which we did. And if you look at the OE0 to OE5, that's the data maturity models, where at each stage we assume that data is not mature, and basically we allow the agents to interact, or the workflow to improve on the data maturity. So that's what we had done as part of our baby steps in the agentic AI journey. I think since some of the roadblocks or challenges and the way forward is, I think AI journey is not for one organization to do because it requires a lot of patience, a lot of investment, a lot of technology maturity. So hence we need to collaborate, not just within the industry, but also the academia and the startup. I think CFOS is a good standard for us, for our industry, but I think it needs to evolve for agentic world. Right now, it's still focusing on data interoperability or data exchange between the various stages of the project. I think it needs to evolve to basically look at the micro data level. So that's what we are looking at. So basically, I'll conclude saying that agentic AI is not about automation or autonomous systems, but it is about aligning people, data, and purpose. Thank you.
Thank you, sir, for the insightful presentation. The session